Now we come to the session 26. We saw the some problems and Cauchy integral theorem. So you are familiar in the properties of integral and complex integral. So, so working procedure to evaluate the problems on Cauchy integral formula of the form integral of f of z divided by z minus a dz and integral of c f of z divided by z minus a to the power of n plus 1 dz over a given closed curve C. See, this is the curve. If first one, the first find out whether the point z equal to a lies inside or outside the given curve C. So you are already know this properties of a Cauchy integral. If the point A lies within the curve, the apply the Cauchy theorem. If outside the given curve, the curve is totally zero. The integral is totally zero. So again, the second one, if z equal to a lies inside the C, then Cauchy integral formula is the form integral of f of z divided by z minus a dz is equal to 2 pi I f I. So this is a Cauchy say if it lies inside integral of f of z divided by z minus a dz equal to 2 pi I f of a. If integral of c f of z divided by z minus a to the power of n plus 1 dz equal to 2 pi I by n factorial in the derivative of a. This is lies inside the Cauchy if z equal to a lies inside the c. If a point z equal to a lies outside the c, supposing that f of z equal to f of z divided by z minus a or f of z equal to f of z divided by z minus a power n plus 1 is analytic inside on given curve C, we conclude that integral of c f of z dz equal to 0 by Cauchy's theorem. See, this is the main result by main property if a point z equal to a lies inside or outside. So by using this property to calculate or evaluate the Cauchy, some problems on Cauchy theorems. So I take on simple problems, evaluate integral of e power to z divided by z plus I pi. So we already discussed some problems and similarly in the same way we take a problems the integral of e power to z divided by z plus I pi dz. First mod z is equal to 2 pi and second one mod z minus 1 is equal to 1. See, if a mod z equal to 2 pi is a equation of a circle with the center as 0 0 and the radius 2 pi. The same way I given the integral can be written as integral of e power z divided by z minus of minus I pi dz. So instead of plus I pi, we taking minus sign minus of minus I pi. So the given problem can be written as integral of e power z divided by z minus of minus I pi. So again that is integral of f of z divided by z minus a dz. Here f of z is e power z and a is minus I pi. A is minus I pi. That is we come to the problem where is the point A is located on this. So this is the unit circle form. It's a circle form. 0 comma 0 is a center. It's a 2 pi. It's a 2 pi on x-axis. 2 pi 0 on x-axis. So similarly 0 2 pi on y-axis. So first coordinate number denote the length of an x-axis. Second coordinate number denote the length of y-axis. Suddenly this is the circle is a circle is a radius is 2 pi means where 2 pi comma 0 in lies the x-axis, 0 comma 2 pi lies on y-axis. Suddenly this is the term. We come to the left hand side minus 2 pi 0. So left of the x-axis minus 2 pi 0. We come to the below y-axis 0 comma 2 pi minus 2 pi 2 pi. So this is the circle is on circle representation of coordinate points and circle representation of a coordinate point. That is, if integral of f of z divided by z minus a dz is f of z is in the form e power z, a is minus pi I. So it's a given problem in mod z equal to 2 pi means mod z equal to 2 pi is a circle with the center 0 comma 0 and a radius 2 pi. So the point z equal to a is minus I pi. Z equal to a is minus I pi. So the point coordinate of the point is 0 comma minus pi. Lies the unit circle or lies within a circle mod z is equal to 2 pi. Means it lies within a circle mod z equal to 2 pi. We have the Cauchy formula. F of z integral of f of z divided by z minus a dz is 2 pi I f of a. F of a. So f of a. So but f of z equal to e power z. So a is minus I pi. So that is f of z is equal to e power z and a is minus pi I. Therefore I am substituting integral of e power z divided by z plus I pi dz is equal to 2 pi I f of a. So that is 2 pi I f of a is minus I pi. So that is we get, if we replace z by e power I pi. So we get 2 pi I e power minus I pi. E power minus I pi. So 2 pi I e power minus pi. So apply the Euler formula 2 pi I cos pi minus I sin pi. So that is cos pi is minus 1, sin pi is 0. That is 2 pi I cos pi is minus 1. That is we get minus 2 pi I. This is the values mod z equal to 2 pi. If we come to the second problem, the same way, if the mod z equal to 1 equal to mod z minus 1 equal to 1 means circle with the center as z equal to a equal to 1, z equal to a equal to 1, the radius is 1. That is, this is the circle, representation of a circle. 1 comma 0 on x-axis. Suddenly the first coordinate number denote the length of x-axis, second coordinate number denote the length of y-axis. Suddenly 1 comma 0 lies on x-axis. That is the point z equal to a equal to 1, the radius 1. That is the center, the circle with the center 1 comma 0. The radius is 1. The point suddenly p of 0 comma minus pi. P of 0 comma minus pi lies outside the circle mod z minus 1 is equal to 1. And hence by Cauchy's theorem, integral of e power z by z plus I pi dz is 0, where c is z minus 1 equal to 1. This is the way to calculate. If outside the circle, the Cauchy integral value is totally 0. Means mod z minus 1 equal to 1. A circle with center z equal to a equal to 1. The radius is 1. Suddenly circle 1 comma 0, radius 1. This is the. So the point is given. Pi p of 0 comma minus pi suddenly lies outside the circle mod z minus 1 equal to 1. Hence by Cauchy's theorem totally 0. The given problem, the given conditions. If we come to the one more example, so evaluate integral of dz by z square minus 4, where c such that mod z equal to 1 and second one c such that mod z plus 2 equal to 1. See, I observe. See the given problems. So given problem integral of dz by z square minus 4. So come to the rationalize 1 divided by z square minus 4. Instead of minus 4, we can write 1 z minus 2 into z plus 2. So rationalize means come to the proper praxis or partial fraction method. This is proper praxis. So 1 divided by z minus 2 into z plus 2. We can write a divided by z minus 2 plus b divided by z plus 2. So again rationale 1 is equal to a of z plus 2 plus b of z minus 2 divided by z minus 2 into z plus 2. So come to rationalize 1 is equal to a of z plus 2 into b of z. So I am using the substitutions. If z equal to minus 2, z equal to minus 2, z equal to 2, if you put z equal to 2, b is eliminated. If you put z equal to 2, b of 2 minus 2, certainly b is eliminated. So we get here 1 is equal to a times of 4a. Replace a, 2 we get. So we get, this is the term, z equal to, we get a equal to certainly 1 by 4. So if you put z equal to minus 2, b is eliminated. So we get 1 is equal to minus 4b. Here this is capital letter. 1 is equal to 4a and z equal to put z equal to minus 2, we get 1 is equal to minus 4b. Suddenly b equal to minus 1 by 4. So we come to problem. I'm substituting 1 by z minus 2 into z plus 2 is equal to 1 by 4. If you replace a is, we get the values of a is 1 by 4 into 1 divided by z minus 2. B value is minus 1 by 4. Minus 1 by 4 into 1 by z plus 2. So that is, we come to the problem. Integral of 1 by z minus 2 z plus 2 into dz is same as integral of a divided by z minus 2 dz plus integral of b divided by z plus 2 dz. So I am substituting the values of a and values of b. That is, we get 1 by 4 integral of dz divided by z minus 2 minus 1 by 4 integral of dz divided by z minus of minus 2. Instead of plus 2, we can write minus of minus 2. So again, we come to the problems. So we come to the problem is a given condition. So what is the given condition? First one, see, such that mod z equal to 1 means z equal to a. Here is a given problem, z equal to a equal to 2. So z equal to a equal to minus 2 in the second term. The first term a equal to 2, in the second term a equal to minus 2. Suddenly both of them lies outside the unit circle mod z equal to 1. So a equal to 2, a equal to minus 2 suddenly is out of this circle mod z equal to 1. Hence by Cauchy's theorem say integral of dz divided by z square minus 4 equal to 0. So z mod z equal to 1. This is the way. This is the properties of integral. If it lies outside, if it lies inside, totally. If it lies inside we get evaluated values. If it lies outside the circle, the Cauchy integral says total 0. So C is a given mod z equal to 1. So the a equal to 2, a equal to minus 2, suddenly point A is outside the circle. So integral Cauchy's theorem is 0. Means integral of dz divided by z square minus 4 equal to 0. Such where C such that mod z equal to 1. We come to the second problem. C such that mod z plus 1 equal to 2. C mod z plus 2 equal to 2. This is a circle. What is the center? Minus 2 comma 0. Center is minus 2 comma 0 and the radius is 1. So we draw a graph. So what is the minus 2 comma 0? Suddenly the first coordinate number, see, minus 2 comma 0. Yes, and lies on x-axis. Minus 2 comma 0. Second coordinate number is 0. Suddenly the point lies on x-axis. So we come to the problem. Integral of dz by z square minus 4 equal to, you know the values of a, 1 by 4. Instead of z square minus 4, we can write z minus 2 into z plus 2. Z minus 2 into z plus 2. So again, I using your proper fractions. Using the partial fractions. This is the proper fractions. You get find the values of a and b. We get a value should be 1 by 4, b value should be equal to minus 1 by 4. We substitute in the method of previous problem. The same way we substituting. So a we get the values should be equal to 1 by 4, b get the values should be equal to minus 1 by 4. So substituting 1 by 4 integral of dz divided by z minus 2 minus 1 by 4 dz divided by z minus of minus 2. That is. So your point is given a equal to 2 lies outside this circle. So a equal to 2 in the first term, a equal to 2 lies outside the circle. At point a equal to minus 2 lies inside the circle. So you observed the coordinate point. The point 2 is positive, lies outside the circle. A equal to minus 2 lies inside the circle. The first term is vanished. The second term, see, the first term is vanished. There is 0. So by Cauchy integral theorem say integral of dz divided by z minus 2 equal to 0. By Cauchy's integral formula, second term dz divided by z minus of minus 2. So here A is minus 2. So I come to the problem. Integral of dz divided by z minus of minus 2 dz is 2 pi I f of a. So a is minus 2. So 2 pi I f of minus 2. What is the minus 2 in the given problem? We come to that. So you get is 1. So f of a is 1 means f of 1. We get 2 pi I 1. So here the problem is given the e power. So we get so here f of z is 1. F of z is 1. So we substitute f of 1. So f of z is 1. So substitute 2 pi I 1 equal to 2 pi. So you come to the right hand side, the given problem. Integral of 1 by z square minus 4 dz equal to 1 by 4. First term is 0 minus 1 by 4 2 pi I 1 into 1. That is, so simplifying 1 term, 2 term get cancelled, minus pi I divided by 2. This is the evaluated here. So if we come to the one more problems. So in form, so evaluate integral of sine pi z square plus cos pi z square divided by z minus 1 into z minus 2 dz, where c such that mod z equal to 3. C such that mod z equal to 3. So again, in complete problem, C such that mod z equal to 3 is a circle with the center as 0 and the radius 3. And the radius is 3 is a given problem. Such that f of z, if you denote this function f of z in the capital letter, sin pi z square plus cos pi z square divided by z minus 1 into z minus 2. Z minus 1 into z minus is suddenly here a is 1 and 2. So this is analytic everywhere except z equal to 1 and z equal to. This point are inside this circle. So this point suddenly a equal to 1, a equal to 2. Suddenly this point lies inside the circle. Mod z equal to 3. So suddenly here consider we come to the partial fractions. This is proper. So if we come to the partial fractions, 1 divided by z minus a, z minus 2. That is, we can write a divided by z minus 1 plus b divided by z minus 2. We can replace again. We come to the a, take 1 is equal to, so 1 is equal to a of z minus 2 plus b of z minus 1. So you can write v is 1 divided by z minus 1 into z minus 2 is equal to, I take LCM, z minus 1 into z minus 2 of a of z minus 2 plus b of z minus 1. So left hand side, the right hand side denominator get cancelled. Certainly I can write 1 is equal to a of z minus 2 plus b of z minus 1. Certainly 1 equal. Now substituting, put z equal to 2, we get the values of b. Put z equal to 1, we get the values of a. Certainly we can write. So a, we get values should be minus 1, b get the values should be equal to plus 1. So a, capital A, we get the values should be minus 1 plus capital B equal to values should be plus 1 by using partial fractions. So certainly we come to the problem. Therefore, integral of sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 dz is, so integral of a divided by z minus 1 dz plus integral of b divided by z minus 1 dz. So substituting the values of a and b, we get a is minus 1, b is plus 1. That is minus integral of f of z divided by z minus 1 dz plus integral of f of z divided by z minus 2 dz. So we come to the simple, find the values of f of z. If f of z is given sin pi z square plus cos pi z square. If you replace z by 1, f of 1 should be equal to sin pi plus cos pi. So sin pi is 0, cos pi is minus 1. Suddenly we get minus 1. If f of 1 is minus 1. With f of 2, so f of 2 sin pi z square is 2 4. You get cos pi z square is 2. We get cos means sin 4 pi plus cos 4 pi. So again sin pi is 0, cos 4 pi is 1. So cos, again I am come to the problem. So I am substituting here the problem in the we get, I am totally substituting f of z is z equal to 1, f of z equal to 2 we get. So minus pi I f of 1 plus 2 pi I f of 2. So minus 2 pi I f of 1 is minus 1 plus 2 pi f of 2 is 1, that is minus 2 pi I of minus 1 plus 2 pi I of 1, minus of minus plus we get 2 pi I plus 2 pi I, totally we get 4 pi I. Now this is inside the circle, within the inside circle we get the values. So we come to the one more problems. Within a unit circle we get the values. So if we get to the one more problem, z divided by z square plus 1 into z square minus 9 dz, where c says that mod z equal to 2. So if we come again, mod z equal to is a circle with center as 0 and a radius 2. It's a circle with center as 0 and a radius 2. So again, simplifying, z square plus 1 equal to 0 means z, the values of z equal to plus or minus I. So which lies inside the circle mod z equal to lies. So it lies inside circle mod z equal to 2. Suppose if z square minus 9 equal to 0. So values of z equal to plus or minus 3. So plus or minus 3. So which is lies outside the circle mod z equal to 2. You observe the given problem, suddenly z divided by z square plus 1, z square minus 9 dz. So I am first to evaluate the z square plus 1. So z square plus 1, suddenly z equal to get plus or minus I. If you values of z equal to plus 1, which is lies inside the circle mod z equal to. So z square minus 9 equal to 0, suddenly values of z equal to either plus or minus 3, which is lies outside the circle mod z equal to 2. Again, come top with substituting. So let f of z equal to z divided by z square minus 9, which is the analytic within and on the circle mod z equal to 2. Therefore, now 1 by, first I simplify 1 by z square plus 1. So again I am simplifying, instead of 1 I write, I am writing minus of minus 1. Again we can write, so 1 by, instead of z square plus 1 we can write z plus I into z minus I. So 1 divided by z plus I into z minus I. This is the proper fractions, is a partial fraction we simplifying. So we get a by z plus I plus b divided by z minus I. Again simplifying by using a partial fractions, we get a value a 1 by 2i, b value minus 1 by 2i. Also so substituting 1 divided by 2i z minus I minus 1 divided by 2i z plus I. So I'm starting integrating. If this z square minus 9 lies outside the circle, instead of the given problem we rewrite the problem. Therefore z divided by z square minus 9 divided by z square plus 1 dz is here 1 by 2 pi 1 by 2i integral of f of z divided by z minus I dz minus 1 by 2i f of z divided by z plus I dz. So here f of z is z by z square minus 9. So therefore f of I, if we replace z by I, so replace z by I divided by I square is minus 1 minus 9. So totally we get I divided by minus 10. So if we replace z by minus I, so f of minus I is minus I divided by minus I whole square minus 9. So suddenly I is plus 1, we get I square. So we totally we get minus of plus 1 we get. So 1 minus 9. So minus 8 we get. Minus I divided by minus A. Suddenly we get I by 8. So given problem, integral of z divided by z square minus 9 into z square plus 1 dz is, now substituting the values. So 2 pi I f of I. So a value is 1 by 2 I f of a is I. Again minus 2 1 by 2 I f of minus I. So we are finding f of I and f of minus I. So substituting. So here 2 get cancelled. 1 by I we get. So 2 by I. F of I is the value I by minus 10. So suddenly we get I by 10. Again, minus I value, f of minus I value 1 by I by 8. So substituting. So I pi divided by minus 10 minus I pi divided by 10. So we get totally equals. So minus pi by 5I. This is the values of the mod C such that mod z equal to 2 in integral of z divided by z plus 1 z minus 9